Now that the basic infrastructure is out of the way, we'll start wiring it into the UI, starting with search. The initial search UI I did in the mockup was very naive. It just toggled the completion on and off. The real Uber app allows us to swipe the search UI down and then pick a location in the map using a pin. This then updates the text field with the selected location. Alternatively, if you type into the text field, locations are suggested to you as you type. There is a great deal of nuanced behavior in this UI, so I only focused on the big ticket features. The first big feature is the swipe down feature, which allows us to swipe down the completion UI as we type. The second is the actual completion UI, where elements update as we type. And finally, the ability to point at a location on the map with a pin and select that location. I didn't implement a lot of the relatively easy features such as bookmarked locations or history in the search UI. Those should be trivial to fill in. In order to implement these, I moved most of the UI logic into separate classes, specifically autocomplete address input and completion container, both of which I'll discuss shortly. A major feature of autocomplete address input is its ability to fold/unfold the completion container. It accomplishes this by binding pointer listeners to the parent form and using them to implement the drag and drop behavior. On the left, you can see the search UI with completion suggestions appearing below. When the suggestions are dragged down, we can pick the location from the map, as you can see on the right. As the map is dragged, the location name is updated into the text field. I refactored some of the code from the map form class into the autocomplete address input class. It made it easier to implement some of the related logic. I chose to derive text field rather than encapsulate it, mostly due to convenience. Encapsulation would have worked just as well for this case. With the exception of these last two variables, every other variable here is in the service of the drag and drop logic. We use the data change listener to send events to the completion logic. However, this callback can be very verbose and it's sometimes invoked by setText. The solution is a special version of setText that blocks this callback and reduces the noise in the completion code with the block change event variable. The last focused text field is the one that now handles the completion. So if the user was in the to text field, everything typed will now impact the completion for to and vice versa. Pointer listeners on the form allow us to detect pointer events everywhere. We bind them in the Init Component method and remove them in the deinitialize method. This prevents a memory leak and a situation where pointer processing code keeps running and taking up CPU. Deinitialize is invoked when a component is removed from the UI or its hierarchy is removed. It's also invoked when a different form is shown instead of the current form. Init Component is invoked when a component is there. It will be invoked if a component is added to an already showing form or if a parent form is shown. You can rely on Init Component and deinitialize working in tandem. They might be invoked multiple times in valid situations. For instance, a dialog shown on top of a form triggers a deinitialize on the components of the form, followed by an init component when it's disposed. Despite using the shorthand lambda syntax for event handling, I need to keep a reference to the drag and release event objects so I can remove them later. The dragged element is always the second element, 0 is the first. It can be dragged between the center location and the south location. If this is indeed a drag operation, we'd like to block the event from propagating onwards. When a component is in the south, we set its preferred size to 1/8 of the display height, so it won't peak up too much. When it's dragged up, we just increase that size during drag. Components in the center ignore their preferred size and take up available space, so we use margin to provide the drag effect. This prevents a drag event on a different region of the form from triggering this event. For instance, if a user drags the map. Dragging just displayed a motion. We now need to remove the component and place it where it should be. We also reset the UI ID so styling changes, for instance margin, unit type, etc., will reset to the default. When we place the container in the south, we set the preferred size and margin to match. When we place it in the center, we set the preferred size to null, which is a special case that resets previous manual settings and restores the default. The location of a text field uses strings, but what we really care about is coordinates on the map, which is why I store them here. This is used both by the map pin logic and by the search logic we will use later.